This lesson is on calculating percents using factors of 100. Now, factors of 100 are useful in very specific circumstances. When you use factors of 100, 1, 2, 4, 5, 10, 20, 25, 50, these are the ones that we can use. We break the part and the whole into equal-sized intervals. And then we use our greatest common factor to determine the appropriate interval. So let's look at an example. We have 42 students who play wind instruments, and we know that this is 75% of the students in the band. So you see a double number line here, and you don't have to draw this. This is just a visual so you can see how it's broken up. We know that 100% of the students here, 100% is the total students in the band. This is our whole. 100% is always our whole. And we know that 75% of them play wind instruments, and that 75% is 42 students. This is our part. Now, we're not using part and whole to do our percent equation, but this just lets you see how it breaks down. Now, we have 100% and 75%, so we are looking for the greatest common factor of 100% and 75%. Now, 25 will go into both of those. So I take 75 and divide it by 25 and get 3. And I know that my 75% has 42 students. So I take 42 and divide that by 3. So I know 25% is 14. So what I've done is I've broken up my 75%. There's 14 students here, 14 students here, 14 students here, and each one of these is 25%. Now, 100% is 4 times 25. So I can multiply my 4 by 14 to get my 100%, and there's 56 students in the band. Another way I could have done this would have been to take my 42, which is 75%. I know there's another 14 in this last 25%. 42 plus 14 equals 56 students total. Let's look at our next example here on our handout. Notice that this is the same problem that we did as a double number line. You see the double number line here. Nick has 7,200 points. This is 20% more than what Adam has. So Adam is our 100% here. Nick is our 120%. Now, what we're interested in is the greatest common factor of 100 and 120. Both of them are divisible by our 20%. So 120 breaks down into 6 parts. I take my 7,200 and divide it by 6, break it into 6 parts. Each one of those 6 parts has 1,200 points. 20%, 3, 4, 5, 6. Each one of these is 20%, has 1,200 points in it. All of these are the same. So I can look at Adam, and Adam is 100%. How many 20% are in 100? 1, 2, 3, 4, 5 of them. I take my 20% times 5. Each one is 1,200 points times 5 gives me 6,000 points. Another way we could have done this is to take our 120% which was 7,200 points, and subtract this 20% here, which is 1,200 points, and subtract that off to get Adam. And once again, that gives us our 6,000 points for Adam. Now let's do a couple of examples. So we are given that 39 is 1% of a number. We want to find another percent. So if we want to find 100%, how many 1% are in 100? Well, there's 100 of them. So I would take 39 times 100. There's 3,900 total in 100%. What if I wanted, let's say, 47%? How many 1% are in 47%? 47. 39 times 47 is 1,833. Now that one's pretty straightforward. Let's look at a different example. What if we know that 39 is 10% of a number? So we take our 100% and divide it up into 10%. How many 10% are there in 100? There's 10 pieces. And this is the back of your percent diagram handout. If you need to see how many pieces, you can just count them up. You can look at your reference and count them up. So now, if I want to find 100%, I take 39 times 10 pieces, 390. If I want to find 70%, I take 39 times 7, because there's 10 pieces in 70%, and that is 273. If I want to find, let's say 30%, how many 10s are in 30%? 39 times 3, and that is 78. 10's pretty easy. Let's look at 5s. Now, if we know 39 is 5% of a number, we take our 100%, divide it by 5%, and that gives us 20 pieces. If you're looking at your reference sheet, you can see that 5% has 20 pieces. So if I want to know 100%, I take 39 times 20, and 39 times 20 is 780. Now, what if I want to know 35%? How many 5% are in 35? That gives us 7 pieces. So I would take my 39 times 7 pieces. And once again, that's 273. And we could also do like 65%. How many 5s are in 65%? 65% divided by 5 is 13. So I would take 39 times 13. 507. Okay? That's not bad. This one, next example, tells us that 39 is 15%. Well, 15, 100% is not divisible by 15. So what we would do here is we would take, we know that 39 is 15%. What percent is 15 and 100 both? What's our greatest common factor? That would be 5. So I'm going to divide both of these by 3, and I get 13 is 5%. And just like we did before, we know that 100% divided by 5% is 20 pieces. So 100% would be 13 times 20, which is 260. I could do my 35% again, like we did above. We know that 35 divided by 5 is 7, so I would do 13 times 7. That's 91. And our last one here, 39 is 25%. This one's easy. 100% divided by 25% is 4 pieces. Each piece, if you're looking at your diagram, each piece is 25%. So if we want 100%, we take 39 times 4, and we get 156. We could also do like 75%, would be 39 times 3. We could do 50%, which is 39 times 2. Factors of 100 is a nice way to kind of quickly mentally find a percent, but it is only useful if you have a greatest common factor of 100. You see here in this last problem, when we knew the 25%, it made it really easy. Oh, it's just 4 pieces, so I can multiply by whatever number. When it was something like our 15% here, it wasn't as useful because we had to break it down into an additional percent and then multiply from there. And if we wanted something like our 35, these two problems, we had to break it down further to multiply. But if we had a 10%, it was really useful. We know there's 10 pieces. I can just multiply it by the number of pieces that I want. So factors of 100 is useful in very specific situations. You know my favorite is still the percent equation, and you know I love a good diagram. So double number lines make the percent equation really easy to see. But sometimes it's nice to do a little bit of mental math and use the factors of 100. So I hope you enjoy doing the factors of 100 problems to solve percents.